Warning: lithium salts are psychoactive. Wear gloves when handling them. Hi guys, here is MIH. Today's experiment is a relatively boring inorganic synthesis of lithium carbonate and potassium bromide from lithium bromide and potassium carbonate. But it has another layer of importance because it is my very first trial on green chemistry. You guys are probably very familiar with this term. Its idea is to limit the amounts of side products produced in a reaction and make them environmentally friendly. I personally will make this even more challenging by not producing any wasteful byproducts, aka having 100% atomic efficiency. Now I'll go through my plan briefly. We start with potassium carbonate and lithium bromide and get lithium carbonate and potassium bromide, which we will cover in this video. The lithium carbonate can be used to prepare lithium hydroxide and then metallic lithium. The potassium bromide can also be turned into potassium bromate by electrolysis. The chain doesn't end here. The potassium bromate will be involved in an even larger cycle of green chemistry to make nitric acid and potassium dichromate, which I will introduce in the next video. Anyways, we will start the experiment now. I measure out 43.5 grams of anhydrous lithium bromide, which actually can be found over the counter as a 50% solution for air conditioning systems. It is then dissolved in a small amount of boiling water. The density of this solution is especially high, and when water is added, it floats on top without mixing. Then, 34.6 grams of anhydrous potassium carbonate is dissolved in a small amount of boiling water as well. The two solutions were then mixed while hot. A lot of flocculant precipitate formed, which is lithium carbonate, and I stirred it around to make the gel clump together. I then prepared my vacuum filtration setup by washing it with a little bit of boiling water. The water heats up the whole apparatus and makes sure that the potassium bromide stay dissolved instead of crystallizing out. It also stops the lithium carbonate from dissolving into the filtrate since its solubility is smallest when boiling. The filtration was surprisingly easy and fast, and no crystallizations were observed. The wet lithium carbonate is then transferred into a dish and placed on the hot plate to dry. After a while, it dried completely into a powder, and I transferred it into a vial for storage. The final yield was 20.31 grams, or a percentage yield of... Wait, what? 110%? Yeah. Sometimes you just have to face the reality that inorganic chemistry, like organic chem and all other branches of chemistry, stabs you in the back every single time. Anyways, that was a joke, and I still love chemistry even though it doesn't love me back. I didn't wash the product with water, so it probably contains some residual potassium bromide, but I prefer yield over purity, so yeah. Remember the filtrate that contains potassium bromide? I attempted to squeeze some more lithium carbonate out of it by boiling it down, and some stuff did actually crash out. I quickly filtered it, dried it, and combined it with the first batch. It weighs a sad 0.23 grams, and it is probably terribly impure, but again, yield over purity. I diluted the potassium bromide solution to 200 ml and set up a crude electrolysis cell using graphite paper anodes and a titanium wire cathode. I didn't do the electrolysis in my cell specialized for chloride production because it can only hold one piece of graphite anode, so it has a much smaller surface area, and it always disintegrates due to the high current density. By using 3 anode plates, I can lower the current density from 40 milliamps per square centimeter down to 10, which is really good for the graphite. Around 10 hours later, to my surprise, a batch of crystals already formed. I did some calculations and determined that the efficiency of the cell must be larger than 90%, which was a really good news to hear. I'll wait until next week and harvest crystals in the next video. See you soon.